Welcome to Study Loop.
So for this problem here, we have a function f of xy, which is equal to negative x squared minus 1 squared minus x squared y minus x minus 1 squared. So we could do some pretty time-consuming calculation, or you could use a derivative calculator, but we get that the partial derivatives are going to be f of x, which is equal to negative 2 plus 6x squared y plus x times 2 plus 4y minus 4x cubed times 1 plus y squared. And then our partial derivative of y is equal to negative 2x squared times negative 1 minus x plus x squared y. So that's what we have there. And we find critical points for the system, so we set these equal to 0. When we do that, we end up getting negative 4x times negative 1 plus x squared equals 0, because we know that x equals 0 cannot be a solution. And then we know that because x equals 0 is not a solution, it must be x equals 1 or x equals negative 1. And that's going to give us these following points: negative 1, 0, 1, 2. So then we look at our second partial derivatives, and we end up getting that when we evaluate this at negative 1, 0, it's going to give us a negative 10, which is less than 0. Then we evaluate it at 1, 2. And when we evaluate it at 1, 2, we get negative 26, which is less than 0. Then if we look at that, we have the delta negative 1, 0, which equals 16, which is obviously greater than 0. And then that for for 1, 2 is going to equal 16, which is greater than 0. So we see that both critical points are maxima. And then, so we've confirmed that they have two maxima. We could graph this to show where those maxima are. It's going to look something like this. We have this figure right here, a sheet-like figure, but then there's going to be these maxima over at the points at negative 1, 0 and 1, 2.